Hello everyone. Welcome back to another exciting episode where we dive into the world of technology. Today is Monday, December 22nd, 2025. I'm your host, ichino-ani. And I'm so happy to have you all here with me today. You know, I usually feel like a teacher in a classroom, watching all these amazing new AI technologies grow up just like students. But today, we have a very special uni student to talk about from the archive. It is a paper that is making big waves in the world of machine learning, specifically in how computers think and solve problems. So, let's get right into it. The title of the trending article we are looking at today is Generative Adversarial Reasoning. Enhancing LLM reasoning with Adversarial Reinforcement Learning. Wow, that is quite a mouthful, isn't it? The kernel for this paper is Chapsit or Perceive. Or about 9512.16917 font. I know it is a bit long, but this is worth checking out if you love digging into the details. Now, let me explain what this is all about in a way that makes sense. Just like I would explain a tricky math problem to my class. Imagine you're taking a math test. You know the formulas. You are pretty smart, but sometimes you make a silly mistake in the middle of your calculation. Maybe you forgot to carry one, or used the wrong logic for just a second. Even if you are a genius, but one small mistake makes your final answer wrong. Well, large language models, or LLMs, were just like that. They are super smart, but they still make these new process errors. They might hallucinate a step, or use logic that looks correct on the surface. It is actually broken. This paper introduces something called the Generative Adversarial Reasoner, or GAR for short. The problem they're trying to solve is exactly what I just described. Current AI models are great at giving answers, but they are not always great at checking their own work step by step. Usually, we train these models by only rewarding them if they get the final answer right. This is like a teacher giving you an F just because your final number was wrong, without looking at all the hard work you did. It doesn't tell the student where they went wrong. So, how does GAR fix this? It uses a very clever method. It actually trains two different AI models together. One is called the Reasoner, and the other is called the Discriminator. Think of the Reasoner as the student taking the test, when the Discriminator as a strict but helpful teacher grading the test. But here is the cool part. They don't just look at the whole test at once. They slice the reasoning process into small chunks, or slices, just like slicing a long loaf of bread, so you can check every. The Discriminator looks at each slice and decides if the logic is sound. It says yes, no, and gives a short reason why. Then, they learn from each other. The Reasoner tries to get better at writing logical steps to fool the Discriminator, and the Discriminator tries to get better at catching errors. This is called Adversarial Reinforcement Learning. It is like a game where both players get smarter by playing against each other. This helps the AI learn much faster and more accurately than before. Let's compare this to other technologies. Before this, we had things called process reward models. These relied on humans to write detailed labels for every step of a math problem. Can you imagine how expensive and slow that is? Humans get tired, but GAR automates this. It creates its own feedback loop, so it doesn't need thousands of humans checking every single line of code or math. It is much more efficient and effective. Now, you might be wondering, ichino-ani, why does this matter to my everyday life? Well, that is a great question. This technology isn't just for solving math homework. The ability to reason step by step and check your own work is useful for so many things. Let me give you 3 specific examples of how this could change our world. First, let's talk about autonomous driving technology. When a self-driving car is on the road, that's to make split-second decisions. It sees a pedestrian, a stop sign, and another car turning left. It needs to reason through the situation. It thinks, okay, pedestrian is waiting, but that car looks like it is not stopping, so I should slow down just in case. If the AI makes a logic error in the middle of that thought process, it could be dangerous. While using something like GAR, the car's AI can constantly critique its own situational judgment, slice by slice, ensuring that every decision it makes is based on sound logic. This makes self-driving cars much safer for everyone. Second, think about medical image diagnosis support. Doctors are starting to use AI to help find diseases in x-rays or make scans, but doctors need to trust the AI. If an AI says, "I think this is a tumor," the doctor asks, "Wait." Standard AI might just say, "Because I think so." That is not good enough. With this new reasoning technology, AI can explain its steps. It can say, "First, I looked at this shadow. Second, I noticed the edges are irregular. Third, this matches the pattern of a tumor." The adversarial training ensures that each step of that explanation is logical and correct. This helps doctors catch mistakes early and saves lives. And third, let's look at stock price prediction and demand forecasting. The financial world is complex. It's like a giant puzzle that never stops moving. Traders want to know not just what the stock price will be, but why it is moving that way. An AI using this reasoning capability can analyze news, market trends, and company reports step by step. It can filter out bad information and build a logical argument for why a stock might go up or down. For example, instead of just guessing, it could reason. Since the supply chain is blocked and demand is high, the price will likely rise. Unless in this kind of detail, checked reasoning is incredibly valuable for businesses trying to plan for the future. So, you see, this paper is really about teaching computers to think more like careful humans. It is moving away from AI that just guesses the answer to AI that understands the process, and that is going to make our technology more reliable, more trustworthy, and honestly, a lot more helpful in our daily lives. Right, that is all the time we have for today's deep dive. I hope you found this explanation of the Generative Adversarial Reasoner interesting. It is amazing to see how fast things are moving. Keep learning, keep asking questions, and I will see you in the next episode. This is ichino-ani, signing off.